Okay, so this is what we're trying to do here. We're trying to build a simple, group selection. And so what you see here is, when you click and drag, we create this, UI interface that essentially grab any objects within that bounds. So in this case, these six, game objects are being selected, and when you click in, we deselect and so on. If you have played any RTS game, this is the game, the features are very common. And so for your project, maybe once you selected these three objects, you might want to move it around, right, navigating around the game world and so on. So it's quite useful. Now let's take a look at how we are going to go on about that. First of all, obviously we need the UI. In this case, we have a simple, let me go to the scene and stop that. We have a simple GUI interface. So here we have a selection box which controls how we click and drag the mouse and create those create that rectangle. And here we have the selection box itself. So the green box that you see here, the canvas, just a reference point to its parent, and then the pointer itself. So the red dot here. Obviously, you can make some change to the how it looks and things like that, but we're not worried about that for now. Now let's take a look at other stuff here, units. So they are what was on the scene here. They have a simple visibility tracker, which we'll talk about it in a bit. Other than that, yeah. So this is all set up. I'll definitely keep this uploaded to my GitHub repository. So feel free to take a look. Now let's take a look at the script. We have two different selection box scripts. One is using a collider. So let's say you work with Unity physics. You can use that instead of this. For now, we'll focus on this more than this one. You feel free to take a look at the script, and you can use it in your project too. And here we have the visibility tracker, which we'll talk about it soon. Anyway, other than that, let's take a look at the code. Here in the selection box script, what we have here is we just made those three reference, right? So the box, the canvas, and then the pointer. So those are what you see or you saw previously. But let's go to the main part. Here in the update function, what we have here is we for every update per frame, every update we want to make sure the mouse that we hover over is always updated, so that every time you move your mouse around, you get this the pointer, the cursor pointer follows your mouse. And then here's the main part where this is when you left click on the screen, right? So when you left click, what this does is it calculates and find the relative point based on your canvas. So it's easier for us to work with a local relative position than a screen position. You can do a quick research on what was the difference of that. But anyway, let's move on. Dragging. So when you drag, we want to expand the width of the the UI, right? So this is what it does essentially. We find those four corners, left, right, top, bottom, and then based on that we find the width and the height, and then we update that, and so on, right? So here we set aside to that, and then once you finish release the mouse, we select those game object or visible game objects in this case, and that's that. Very simple logic that went through that. You left click, you drag around, and then you released. And here I was just mentioned briefly where we just want to make sure that what do I call it, pointer cursor. So this is the cursor that you'll be the red dot that I mentioned before. Will get up to date and then move around in the screen. And here is the selection logic. So let's go to the visibility tracker. So what we have here is when the game objects become visible. So if they are within the camera view or the game scene view, they will be added to the list, or we call it visible objects. The reason is that in your game you could have thousands of game objects that you may not be interested in selecting, for example, right? So you only care about those game objects that are within what you can see, right? It's obvious, but this is one of the ways to keep track of that. So when it becomes visible, you want to make sure that that is added to the list so that later on we can select them, right? When it becomes invisible, then we remove that from the list, right? So that again, let's say you have thousands game objects, right, in your game, but you only see, let's say 100 of them. You don't want to be finding like thousands of objects to see if one of them is within the selection. So it can get quite big in essence. So here, let's take a look at the select visible objects. So what we do here is, from previous logic here, we want to keep track of the minimum and the maximum screen, so that we can find out where or if the game objects is within that bound. So what we do is we need to first convert the game objects world space or world position into a screen space. So essentially you convert 3D position into 2D position, which could depending on how your camera is angled, right? So your camera could be rotated 45, 35, I don't know, however long, right? You can use this function called I believe it's called here. I didn't see it. Here, world to screen point. So it converts the based on your camera. So this should be your main camera. From your main camera, it converts that into a screen point. And so within that, you can use that screen point for each game object to find if whatever that game object is, within those or within that the bound. In this case, it's relatively within that those bounds. You want once we figured out, then we know that those are selected, right? So we keep track of which one which objects are being selected. When they're selected, we in this case we change the color. Or here we change the color to light green, right? And when when it becomes not selected or deselected, we just revert it back to the original color or the original state. Yeah, I mean it's a very quick video. I hope you enjoy this and have a good day. Bye bye.